polar form of shear equation. Let f of z equal to u of r and theta plus I v of r and theta. U and v are functions of r and theta, where z equal to r e power I theta or z equal to r comma theta. Say so this is the polar plane. Here each line is r, so this is r and this is theta, so this is point z, say. Now if f of z is differentiable, then f dash z will be limit h tending to 0 f of z plus h minus f of z whole by h. So suppose h is approaching 0 along a radical axis or path where theta is constant. Say h equal to del r e power I theta. So it is not equal to 0, h is not equal to 0. Then f of z plus h minus f of z whole by h kete asijibo? It will be f of z plus h will be u of r plus del r comma theta, u of r theta plus I v of r plus del r comma theta minus u of r theta plus I v of r theta whole by del r e power I theta, because f of z equal to u r theta r plus del r e power I theta. I partial derivative of v with respect to r, or ur plus ivr by e power I theta. So f dash z as this is as h tends to 0, so f dash del theta so h is equal to r e power I theta e power I del theta, sorry, h equal to z minus r e power I theta e power I del theta, where z equal to r e power I theta. So this will be, okay, sorry, h equal to r e power I theta e power I del theta minus z. So this becomes r e power I theta e power I del theta minus 1, where del theta is not equal to 0. Now f of z, the quotient f of z plus h minus f of z whole by h becomes u of r comma theta plus del theta minus u of r theta whole by r e power I theta e power I del theta minus 1 plus I v of r comma theta plus del theta minus v of r comma theta whole by r e power I theta e power I del theta minus 1. So this is u theta plus I v theta, and this is precisely this will be u of theta plus I v of theta when we apply del theta approaching to 0, but when del theta approaches to 0, this also becomes 0. So we have to adjust this one before doing something. So we have to adjust it first before writing the equation. This is equal to I del theta by e power I del theta minus 1 and 1 by r e power I theta. And this is the same. Now here, this is an identity. This becomes 1 as del theta goes to 0. This we know. One by e power I theta ur plus 1 by e power I theta Vr I equal to 1 by I r e power I theta u theta plus I v theta. and this becomes after suitable adjustment we are going to get this is 1 by I minus I r e power I theta u theta plus I v theta, and this becomes 1 by r e power I theta v theta minus I u theta. Now comparing both sides. We get u of r equal to v theta by r and v of r equal to minus u theta by r. So this is what is known as polar form of CR equation, Cauchy-Riemann equation. Okay, by dou z will be 1 by dou z by dou r. This is 1 by dou z by dou r, and calculating it we get e power minus I theta plus and also f dash z will be dou f by dou theta and dou theta by dou z, and this is precisely u of theta plus I v of theta, and dou theta by dou z is 1 by dou z by dou theta. That will be e power minus I theta by I r. We could calculate it dou z by dou theta. I r e power I theta. So dou theta by dou z equal to e power minus I theta by I r. Now again comparing we get the shear equation. Okay, so this is the proof of shear equation, and the next topic is power series. Our series representation of analytic functions. There is a requirement for that, which is sequence and series, which we have not covered yet, so we will do that in next class. After that we will study power series. So aji pai etiki thau. I will share the notes. जहाँ जहाँ किसी असुविधा अच्छी डाउट अच्छी बर्तमान you can ask in the WhatsApp group or either in the Teachment app through text message. Right now